Hello everyone, welcome back to the channel. So today we'll solve the daily challenge from Leetcode. So let's see the question first, which is the maximum element after decreasing and rearranging. This is a medium level problem, and you are given an array of positive integers array. Perform some operation, possibly none, on array so that it satisfies these conditions. What are the conditions? Okay, the value of the first elements in array must be 1. The absolute difference between any two adjacent elements must be less than or equal to 1. Okay. And in other words, ABS, that means absolute value of array of I minus array of I minus 1 is less than equal to 1 for each I where 1 lesser than equal to I lesser than array dot length. Okay. This is a zero index array. Okay. ABS of X equal to absolute value of X. Perfect. Now, there are two types of operations that you can uh, perform any number of times. Okay, uh, decrease the value of any element of array to the smaller positive integer. Rearrange the elements of array to be in any order. Okay, okay. So return the maximum possible value of an element in array after performing the operations to satisfy the condition. Okay, so the question is very easy, and we have the two operation decrease and rearrange the array, and we need to make sure that the first element of the array must be 1, and the absolute difference between the two adjacent array must be less than equal to 1. Okay, and we need to find the maximum possible value of the element after performing the array. Okay. Okay, so let's see the example one. As an input, array equal to 22121. So you can see that this is not the first element is not 1. So make it 1, and then it will be 2, then it can be 2, and then it can be 2 as per the question, and then it can be 1. Doesn't matter. So this is how the largest element will be 2 in this array. So let's see the next example, which is array. So the array has 100, 1, and 1000. Okay. So 100 is not 1, so it will be 1. Then this should be 2 because the maximum it can be 2, because you know what, they have given that you have the condition that absolute value between the element of two adjacent element will be less than equal to 1. Okay, so then it can be 2 maximum. Then the third element can be 3 maximum, because then only the absolute value absolute difference between them will be 1. Okay, so the maximum element as per I say that it will be 3. So that is why the output is 3. And this is the last example. Add equal to 1, 2, 3, 4, 5. This is already in one kind of sorted order. So you can see that first element is 1, and the absolute difference between every adjacent element is 1. Okay, so that's why we don't need any changes. So the maximum value is 5 here. So the output is 5. Okay. So now let's solve the question. So how can we solve the question? That we can sort the element. Yeah. After sorting, you can see that in this case we find out the 1. If there is not 1 in the array, what can it be? We can have some extra integer which we can replace every time, and we can check what will be the maximum value. So let's solve the question by writing the code. So let's sort the array first, okay? By using the sort function array dot begin, array dot end. Then what can we do? So we can use a array integer x equal to 0, okay? And every time we will just increase the x, okay? Int I equal to 0. Let's have a for loop for 0 to array size minus 1, okay? It will go up to 0 to n minus 1. where n is the array size. Sorry. Okay, yeah. So what can we do right now? That we can check also use that the first element must be one. So for that case, to check everything, we can use that x every possible time it will be plus one because we need the maximum possible value. It can be maximum one, and we just add it at minimum. I'll tell you why I have taken the main and the array of I. Okay, so X will give the perfect answer because let's see the example 2. Here in this case, after sorting, it will be 100 and 1000. Okay, perfect. Then in the first iteration, where I equal to 0, we got 1, so we don't have any kind of changes. So minimum of x plus 1 is equal to 1 and array of I is 1. So minimum is x will be 1 for the first time. And when the second time it will happen then the array of I will be 100 and 100 then it will be 1 plus 1 it will be 2 so the x will be the new x will be updated by 2 okay and now x equal to 2 then in the last case there will be 100,000 and the when comparing with the 1000 and here will be 2 plus 1 3 1000 and 3 3 will be minimum so 3 will be added at the x and it will be the maximum of this whole array so we'll just return the x as the answer. Now we'll just run this code. I hope there have not any kind of errors. Yeah, as you can see that this is the accepted code. Now let's run the code. And before running the code, let's analyze the code first. Okay, you can see that we have used the sorting algorithm, which takes up to n log n time in the worst case, and we have taken a O of n for loop. So the time complexity for this case will be what? O of n log n. Okay. So what will be the space complexity? We have not take any kind of extra spaces. We just take a x, which is the constant every time, and so that's why the space complexity will be O of n, which is a constant space. So yeah, that is it. Okay, this is the space complexity and the time complexity. So now let's submit the code, and I have submitted, and let's see. I hope there will not have any kind of errors. Yeah, so that is the thing. We have run this code, and this is a good code, and that is it. Thank you guys for watching this video. I'll see you in the next time.